Hello, we are live.
Are we live?
We are live.
Okay.
And I'm semi-transparent again, because apparently on Mondays, I wear clothing that doesn't want a green screen.
Okay. Let me just find the chat.
I'm
definitely on borrowed time now. Boy, did Darwish switch the venue.
Oh no, what happened?
32 degrees yesterday.
Oh God!
Yeah.
That's wrong.
It's so wrong. Yeah. We broke 15 records across the province for highest temperature.
Oh no.
Hello,
real fake admin. Hello, Phoenix.
The nice thing is that it's really cold at night still, or not really cold, like 12 degrees.
So that means you're at like 0% humidity.
No, we're like 50% right now.
Yeah, 50% still quite low.
Yeah. So it heats up in the day, cools down at night, and so we should have an even worse day today. Like, I wouldn't be surprised if we get closer to 33, 34. And like, you remember that when we had that record heat wave, it was 39, and like, we had some 35 days, which were bonkers.
Yeah, that's wrong.
And so hopefully the temperature should settle back down again starting tomorrow. Let me see. Although I wouldn't be surprised if it sticks around longer than we've been. Yeah, tomorrow will be more like 24 high.
Okay.
And then it should be nice for then it should just be like 23 for the next 10 days. So why does Fraser's audio cut in and out all the time? Does my audio cut in and out all the time?
I'm not hearing you cut in and out. I don't know.
The one thing that I definitely have problems with is Discord.
Yeah, Discord audio is special.
Yeah, not special, like pushy. So it just tries to take over everything.
That is true. You have to not use Discord with the same mic you use for other things.
Yeah.
Okay, other people are hearing it. That's weird. I'm showing 3 dropped frames. This shouldn't be from me. But it must be from me because I don't hear it.
Right. But then they would hear it from you as well.
Yeah, that's deeply confusing.
Yeah. Let me see if I have I just shut down every single thing. Let me just do a recording here.
So we're peaking. Let me turn down the output.
Peaking.
Yeah, so I've turned down the output so that we shouldn't be peaking anymore.
Okay. That might do it. When I get really excited and yell.
Okay.
Very brief, spasmodic clipping, but only from Fraser.
Okay. Hopefully it will stop now.
Let me just make sure all the plugs are plugged. We plug the plugs. Okay. I'll try that. Oh, my audio is okay now. Paul Dizzy says his audio's been doing that for years. Huh. Yes. All right. Should we begin then? While we still can?
Yeah, we might as well. Do you have bad weather coming in?
Bad weather coming in?
Well, you said that we needed to do this because your days were measured. And when I say that, that means there's a tornado coming.
No. The temperature is rising and it causes my camera to shut down. It overheats and shuts down.
Okay.
So, yeah.
That's special.
Mm-hmm.
I feel like you need to get a gel cooling pack to wrap around your camera.
Sure. Yeah, maybe I'll do that. Maybe I'll just immerse it in water.
No.
It should be waterproof.
I still feel like you'd get a better image if you wrapped it in a gel pack.
All right. You ready?
Yeah, let me start up a new audio file. New audio file. What is our episode number? The recurring question.
682.
Okay.
Temperature in here right now, 73. It was 72 when I started, now it's 73.
Oh God.
That's Fahrenheit.
Yeah, no. I understand that's Fahrenheit, but that it's rising fast was what I was being sad
it
on
probably
your
will take
behalf
a while
about.
to get to 74. I got it shut down pretty nicely though, so we'll see what happens.
All right, I am pressing the record. I am pressing the other record.
Okay.
I am recording.
I am also recording. Here we go. Astronomy Cast, episode 682, Ultra-Diffuse Galaxies and Dark Matter. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well, and I have exciting news.
I'm ready.
We have started releasing Escape Velocity Space News as a podcast. So if you're not into the whole sitting down in front of a TV and watching stuff on YouTube, now you can just listen to us while you do whatever it is you're doing. So check it out wherever podcasts are found.
So search for Escape Velocity Podcast. And
Space News, sadly. There's a bunch of Escape Velocities.
There's a bunch of Escape Velocities. So Escape Velocity Space News Podcast featuring Dr. Pamela Gay and friends.
It's true.
Okay. There you go. And how often are you releasing episodes?
So we have a back catalog, and right now we're releasing about 2 a week as we get through the back catalog, and then it will be 1 a week in the future.
And how long are they?
They're about 40 to 50 minutes.
Okay, great. Astronomers first noticed the strange behaviors of rotating galaxies almost 100 years ago, suggesting there's an invisible dark matter holding them together with gravity. Or maybe we just don't understand how gravity works at the larger scales. Observations are much better now, and astronomers have found examples of galaxies that are almost entirely made of dark matter. Does this tell us anything? We'll talk about this again in a second, but it's time for a break. And we're back. All right. Hey, what's dark matter?
It is stuff.
Okay.
It is stuff that does not like to interact with the electromagnetic force.
But no conclusive answer?
It's stuff.
Stuff.
My personal feeling is it's going to be a mix of axions and sterile neutrinos that get us to the correct temperature profile.
We should... I think the answer, based on the conversations that I've had with astronomers so far, is, I think you're on the right track there. It's going to be a whole bunch of things.
Yeah.
It's going to be, it's a few primordial black holes, a few rogue planets, a few axions, some other particles that we don't see.
Yeah. A lot of axions.
A lot of axions, some sterile neutrinos, some, right? Like just a whole bunch of stuff. So we don't really know.
Yeah.
But what is, even though we still don't know, like we could go back and talk to Fritz Zwicky in 1930 and say, like, what is it? And he would be proposing the same kinds of things that we're talking about today. The key, I think, is that astronomers have gotten so much better at mapping and observing it. So what is the modern state of observing dark matter?
So there's two primary approaches. One is to look at how dark matter changes our ability to see the universe behind it. Matter in general has this wonderful attribute of being able to bend light with its gravity. Dark matter is matter. And as light from background galaxies shines towards us, dark matter has the capacity to change how the light moves through the universe. And what's really cool is we expect on average that if you look at a swath of sky, all the different galaxies with all their different edge on, face on, twisted, all their different shapes should average out to a disk. And when we move our swath across the sky, what we see is over here you have teardrops. Over here you have Christmas trees as the average shape in those swaths. And those non-round shapes tell us the distribution of dark matter that is changing how these background galaxies look. And we can actually start to do it in different distances where we look at galaxies super far away. How are they distorted? Look at the middle distance. How are they distorted? Look at the closer by. How are they distorted? And this gives us a three-dimensional map of dark matter on the largest scales. And then on smaller scales, we can look at things like the bullet cluster, where you have two clusters of galaxies slamming together, and you can map out the dark matter in that system by looking at everything behind it. So we use gravity. Gravity is pretty much the only way.
And these maps at this point are quite comprehensive.
Yes.
Like, they have observed huge swaths of the sky, mapped out the distortions, and used that to reverse engineer where the blobs of extra gravity are. And there's some wonderful, like, 3D visualizations of these, and they really look like kind of blobs that surround. So if you look out and you see the galaxies, the giant galaxy clusters, and you see them in these lines and walls and structures like that, if you could see the dark matter, just everything would be surrounded by big blobbers of some kind of invisible stuff. And that's the part that really amazes me is, we don't know what it is, but we know how to use it as a telescope is the joke that I always make.
And it's so frustrating that particle physics requires us to understand the universe at the tiniest and the largest scales, and getting in both directions simultaneously requires twice the equipment. We'll get there eventually.
And so here we are in mid 2023.
Yes.
And what is the state of the art? What stuff can we dispose of? What ideas can we throw out? And what ideas remain about what this is? Like, how well have we at least constrained the problem?
So the other way that we were getting at the distribution of dark matter was to look at how galaxies rotate as a function of distance out. And one of the thoughts was galaxies might just be full of dark material. There might be a bunch of super cold white dwarfs hanging out, being very old and not illuminated. There could be a ton of black holes, stellar mass and smaller, out there hanging out darkly. And all of these not giving off a lot of light things that we're just not noticing could add up to be the dark matter that we need. It turns out that roughly the amount of dark matter necessary to explain what we observe could be accounted for if you took one Acme brick, and let's face it, Acme bricks don't give off a lot of light, and put it in every solar system sized volume of space. And all those bricks would add up to what we need. So astronomers went out and looked for the gravitational lensing of individual background stars that we would see if, like, a black hole passed in front of the background star, if a cold white dwarf passed in front of the background star. And we saw plenty of things get gravitationally lensed, but we didn't see enough to add up to be all of the dark matter that we expected.
Right. And I mean, have we been able to at least rule out some stuff?
Yes. So we have ruled out large populations of white dwarfs that are cold neutron stars and rogue stellar mass and smaller black holes. So we've
like I recall if black holes, if dark matter is black hole, then they either have to be greater than 1,000 times the mass of the sun or less than the mass of an asteroid.
Right.
You can't have anything in between. Like, those have all been ruled out. And similar things have been ruled out for particles, for various types of particles, various behaviors of particles, and then in particle accelerators like CERN, they've been able to rule out masses of particles that
Yeah.
could account for dark matter.
So we keep not creating weakly interacting massive particles. Particle physics, basically you take two particles, slam them together with vast amounts of kinetic energy, and the combined kinetic energy and mass energy turns into new particles. We also use giant tanks that are looking at cosmic rays and other particles to see how they interact with the material inside of these vast tanks. All of these different ways of looking for dark matter, neutrinos, other things that are just very temporarily around, we look for in these ways, and supersymmetry hasn't been proven true. That entire second family of particles that we were expecting, not there. Weakly interacting massive particles, not there. And as we look more and more at what was necessary to get the cosmology that we see, the rate at which galaxies formed, the amount of galaxies and superclusters and large scale structure that we have today, you also need particles that have a certain, we say temperature, that just means how fast they're moving. And weakly interacting massive particles don't have the right temperature profile to be the kinds of stuff that we were looking for.
Right. So, like the hot neutrinos, the things streaming from the sun, moving at close to the speed of light, they wouldn't remain
Yeah,
and clump around galaxies in the way that dark matter seems to do. So we can kind of
exactly.
rule out these fast moving particles. So
Yes.
whatever it is, it has to be slow. Um,
But not
and
too
yet it's
slow.
not too slow, and it has to interact almost never, because
Yeah.
larger and larger tanks of water, the kinds of things that have found neutrinos, have failed to
Yeah.
find these dark matter particles. And yet, like whenever I post videos about this on YouTube and stuff, I just get tons and tons of comments of people rolling their eyes and going, all scientists making up stuff again. But like, if you made the same observations that astronomers did, you would come to the same conclusions
Yes.
that this stuff is there,
Yeah.
that we just don't know what it is. And you have a whole series of wonderful analogies to sort of go into, mysteries.
This is the stuff I just love. And with dark matter, I had one very stark moment in graduate school. We had just had a seminar speaker that was talking about modified Newtonian dynamics. And I walked into one of my dissertation advisor's offices, and he is hands over eyes, glasses off. And I'm like, are you okay? And his response was something along the lines of, I think it's true. I think there could be modified Newtonian dynamics, because at that point in time, we didn't have all the observational evidence that we have today for the distribution. And the frustrating thing is, even today, there could also be this extra term to gravity.
Yeah.
So we are in this situation where we know the universe likes to improv. We know that it's all about both and.
Yeah. I wish I could, like, you say to the person, okay, take a powerful telescope and observe the rotation rate of a
Yeah.
galaxy. Okay,
Yeah.
great. It's a straightforward process to do. You measure the red shift and the blue shift depending on which side of the galaxy that you're looking at. Okay, great. Now count up the total mass in the galaxy and work out how fast that galaxy should be rotating to tear itself apart. It should have torn itself apart. It doesn't.
Yeah.
Can we agree on this? Okay, great. Why? And that's it. That is the beginning of the question of what is dark matter. Why isn't that galaxy tearing itself apart?
And then we
Either
get to
has invisible mass, or we don't understand gravity.
and then we get to the nominal topic of today's show, which is
Yes.
ultraluminous galaxies, which are out there going, "Hi, We're here to show you dark matter is at least mostly made of stuff, because we either have it or we don't in large amounts. Look at
Okay, well, we're going
us.
to talk about that in a second, but it's time for a break. And we're back. So what is an ultra-luminous galaxy?
I meant to say ultra-diffuse
Ultra-
galaxy.
And we're back. So what is an ultra-diffuse galaxy, which is what you meant to say?
It is what I meant to say. It's a Monday, humans. It's a Monday.
Well,
So,
ultra-luminous galaxies are a thing, and they're really
right,
interesting, and
they
maybe
really
that's another
are.
episode.
Yes,
So
it's just not this episode.
that's not this
So,
episode, yeah.
an ultra-diffuse galaxy is a galaxy that has 10 to 100 times fewer stars and pretty much no gas when compared to the Milky Way, but is spread out over the same volume. So you literally take part of a galaxy and go splump and just spread it out and strip it of gas, and then try and find other similarities and realize there are none. They're all different. And they're weird. And what's really awesome is our examples of galaxies that have absolutely no dark matter, where the rate at which stars are moving in the system correlates directly to how much visible stuff is in the system. Those are ultra-diffuse galaxies. And at the same time, some of the systems that we look at that have the most dark matter, also ultra-diffuse galaxies.
And so we've got like two examples, or we have like two flavors of extreme here. We have
Yeah.
galaxies that have enormous amounts of dark matter and very few stars. So when you look at it and you use it as a lens, it acts like a gravitational lens of a much more massive galaxy, and yet
Yes.
you barely see the stars in it. And then you have the other version of it, where it's a very bright galaxy, and yet it acts like a gravitational lens of a galaxy that is far less massive than it is, because
Yeah.
it has very little
It's
dark
never
matter.
ultra bright. It's just only as bright as its stars allow.
Right. Yeah, bright in comparison to the
The amount of
ultra we talked
mass.
about.
Yeah.
Yeah,
So the
yeah.
mass to luminosity ratio is the way we usually talk about it. And these systems are consistently like 10 to 100 times smaller than the Milky Way in terms of luminous stuff.
Right. And so what makes this weird is that the amount of dark matter ratio to regular matter
All
can
over the map.
change.
Yeah.
And so you can have galaxies which have had their dark matter stripped away, and galaxies which have had their stars stripped away,
Right.
and every flavor in between. And then there's like an average. Like on average, you're going to get a galaxy of matter and 10 times as much dark matter. But you can get edge cases on both sides,
Yes.
which is weird. And I guess that's a problem for the modified gravity idea.
Right. It puts limits on it. It doesn't rule it out completely. It just puts limits on it. And that, like I said, the universe is an improv artist. So what we're beginning to think is true with these systems is they didn't form the way we see them. They've gone through things. They've seen things. It appears that if you trace back the motions of these systems, you can trace it back to some sort of a massive interaction in the past. These are potentially the splashes of galaxy given off during massive collisions, and in some cases they take their dark matter with them, and in some cases they don't. And it's that sometimes they do, sometimes they don't, that means dark matter is stuff. Yet
And
again.
what is the mechanism that could strip the dark matter out of a galaxy?
We're still figuring that out. I mean, it's one of these things where we know that dark matter in general doesn't have the same collisional cross-section that like an electron or a proton or any normal kind of matter that we're made of would have. You throw electrons at each other and they're willing to collide. You throw particles of dark matter against each other and they're collisionless for the most part. It's like rolling BBs through a theater. Most of the BBs won't manage to hit a chair leg because they're so small compared to the emptiness between the chair legs. Now, if you're in one of these circumstances where you have different velocities of interactions, the thinking is, well, maybe if they collide in some ways, this lack of collisionless, this lack of words are hard. The way that some particles just don't seem to collide can cause the dark matter to pass through along with some of the splashed out material. And now you have a dark matter rich scenario where in other cases, due to differences in the velocity of the collision and differences in how everything comes together, you can end up with the dark matter lingering behind while some of the splash carries on by itself.
All right, we're going to talk
Figuring
about
it
this
out.
some more, but it is time for another break. And we're back. So, what's interesting about this research is that some of these ultra-diffuse galaxies have been found relatively close to the
Yes.
Milky Way. So, this is not the kind of thing that you would see shortly after the Big Bang, but in fact, we're seeing them within our universe neighborhood.
And what's frustrating is we just don't know when they started forming, because the whole ultra diffuse part means they're super hard to find.
Right.
And we're starting to build new systems that are designed specifically to go looking for these kinds of low surface brightness things. But we have luckily been able to find a few of them relatively nearby that gives us the chance to basically go spelunking through the data, looking for supermassive black holes, looking for details on the stellar motions, and that nearbyness makes all these kinds of research questions possible.
Yeah, yeah. I mean, do you want to talk about like specifically the research that's done? You say it gives some new methods of research. Like what can you do when it's that close?
So when it's that close, you can literally start going and looking at how fast are the different stars going? What are the stellar populations involved in this? Is there any gas? You can start looking for the 21 centimeter line of hydrogen to try and find any cold gas that might be there. And there is a new telescope system called Dragonfly that is basically using a whole bunch of big old telephoto lenses to look extremely deeply into the region of the sky that was explored by the Sloan Digital Sky Survey. They're looking at that area because there's already good background information, there's already good calibration, and there's spectra of pretty much all the bright stuff that Sloan could get spectra of. So they're going into this knowing, okay, we're finding the diffuse stuff that Sloan probably wasn't able to see, but now we can put it into context. And this allows us to basically see, how do we take normal galaxies and evolve them out to be what we're seeing with these ultra diffuse systems.
What do you think the future would hold for one of these galaxies? I mean, because they don't have a lot of gas and dust in them
Yeah.
left, a lot of stars.
Yeah.
Are they going to sort of fade away?
Yeah. These are systems that are very transient in nature. We've seen some of them that are far, far away from whatever cluster it was that shredded them. And so you have these broadly spread out collections of stars that are going to age away, fade away. They are going to have mass being given off through supernova and other activities, but it's probably not going to be enough to recoalesce into new epochs of star formation. They're just going to fade from sight, and it's sad and awesome all at the same time.
Um, do you think we will crack this problem in our lifetime?
Yes. It's one of these things where science advances at the rate of technology and instrumentation. We see with Dragonfly the instrumentation we need to find more of these systems that allow us to get more statistically rich understanding. We are also starting to get better and better computers that allow us to run the simulations. We have for a long time focused on how do we replicate the tadpole? How do we replicate the mice when looking at how galaxy mergers
Those are
occur?
galaxies, by the way.
Yeah, sorry. These are
The
merging
tadpole
galaxy
galaxy,
systems.
the mice galaxy.
Yes,
Yeah.
yeah. Good. A very important clarification.
Yeah. Yeah.
Um, what we haven't been as focused on trying to understand is what happens to those tidal tails that get stripped off in the long run? What happens to this material that is cast off in the long run? With more computational power, we start to be able to understand the leftovers as well as the core material. And as we look at bigger and bigger systems in our simulations, as we look at more and more parts of our simulations, I suspect we're going to see these ultra-diffuse galaxies basically falling out as the splatter of these massive collisions.
Yeah. I wonder if, finding one of these relatively close, and because they're so hard to observe, I wonder how much of the distribution of the mass of the dark matter is coming from them. I don't need an answer. I'm
Yeah,
just like,
yeah.
I'm just wildly speculating. Like, I wonder if things like Dragonfly or even that idea of better technology, of better ways to survey the surroundings, that we might find, okay, we actually see that the dark matter is actually torn up into small pieces and is part of these little galaxies. That would be really interesting, as opposed to it being necessarily like, when you resolve it with enough resolution, you can start to see where that distribution of dark matter is more specifically than it's just hand wavy kind of around the galaxy.
And dwarf galaxies in general are deeply confusing. Some of them will have a mass to light ratio in the hundreds because they are dark matter extremely rich. Other systems will be in the tens. And trying to understand what kind of evolutionary history goes into just your regular everyday dwarf galaxy having this range in possible mass to luminosity ratios, and then extending it out to bigger systems that have probably resulted from massive galaxies colliding. The physics is awesome and complicated, and I'm really glad I'm not writing those kinds of simulations. And
Yeah.
I adore the work coming from the people who are writing those simulations.
Wonderful. Good luck to them.
Yeah, seriously.
We'll see you next week, Pamela.
See you next week, and thank you to all of you out there who make our show possible through all of your donations. This week, I would like to thank Jeremy Kerwin, Stuart Mills, Harold Bardenhagen, Claudia Mastriani, Daniel Loosely, Scott Bieber, Georgie Ivanov, David Gates, Scott Cohn, Jim Schooler, Justin Proctor, Marco Irasi, Matthew Horstman, Kimberly Reich, Alex Cohen, Tim Garish, Tim McMacken, Cooper, Gregory Singleton, Kansaya Penflienko, Matthias Hayden, the Big Squish Squash, Jeff Wilson, Disastrina, and Paul D. Disney. Thank you all so much for everything you do.
Thanks, everyone.
Bye-bye. Okay, there's some paper you read that I wasn't answering the questions the way you wanted me to. What paper have I not read?
I don't think so.
Okay.
I mean, there was a nearby dwarf galaxy that was almost entirely. No, I think we did.
Okay.
No, you're fine.
Okay.
You're fine. Yep. No.
I can never tell from your reactions. Okay, so how bad's the temperature there?
What am I now? 74.
Ugh.
Yeah,
Ugh.
I'll make it. It's the show that I have to do at 5 o'clock. That should be. Well, hopefully, I'm no longer in here. I'll leave everything to just stay cool.
Yeah.
Okay.
All right, looking to see.
Go ahead and ask your questions. Chad, so thanks, John. Chad says he's working on the plugin right now. It looks like YouTube did change something.
Oh,
So
okay.
we're working on it for tonight.
Okay.
Although we'll see. I might cancel. We'll see. If it gets too hot, I can't just make my camera behave. Okay, I'm uploaded. Man, I love having fiber. 74 isn't that bad. No. Gordon, the key is that it's gone up 3 degrees in the last half hour. So it's gone from 71 to 74 in 30 minutes.
It's the delta.
That's the issue. Okay. I'm ready. Let's see. Hal McKinney asks, what if dark matter is the medium for gravity?
So we know that gravity is communicated by the graviton boson. Forces are communicated through bosons.
We don't know that.
Well, it's the particle that is like wedged in between all the things we have observed.
Right.
So there is either no boson that communicates gravity, which actually I kind of like, my heart is like, gravity doesn't fit. What if it is the shape of space?
Yeah.
So gravity is either not needing a boson because it's the literal shapes of space, or it's communicated by the graviton, which is massless and thus not something that we can detect. And we now know that gravity does travel at the speed of light. So there's that at least. I forgot where I was going with this.
Is dark matter the medium for gravity?
No. It is simply something that interacts with gravity. Same way you and I and the planet and the moon all interact with gravity.
Hal also asks, are ultra-diffuse galaxies indicative of beginning and or end of galactic existence?
No, they're just a thing.
They're outliers.
They're like a bus driving down the road and splattering the sidewalk with a puddle.
They're like seeing a supercar when you're driving along in the city.
Fair.
Just like something, they exist and they're rare and they're weird. And some rich person drives it.
It all costs money over on Twitch was like, wait, what? Hold up. We know gravity travels at the speed of light. Can someone please elaborate on that for me? Last week's episode, go back, watch it. So the 2017 gravitational wave detection from neutron stars, where we also saw the optical afterglow, the combined information allowed us to go, yes, gravity and light travel at the same rate. And it's awesome.
Yeah, so we saw the gravity waves and the radiation arrive at roughly the same time.
Yeah.
I don't see any more questions. Let me see.
Have you tried Bard yet?
No, not allowed to.
Why?
Because I'm Canadian.
Oh.
Let me see.
I'm displeased on your behalf.
Yeah, it's available in 180 countries, but not Canada. Bard isn't currently supported in your country. Stay tuned. Nor anyone in the European Union.
Okay.
And I don't have the additional functionality, the plugins and stuff for ChatGPT yet. Yeah.
Well, those they only gave out to like a subset.
They're rolling them out to everybody now.
But not to Canada?
Yeah.
That sucks.
Yeah, I think from what I understand, there's like some requirement. Like I know in the European Union, like Google has to meet their requirements for privacy and such.
Yeah, that's actually a real problem.
And they've chosen not to, or are holding off.
Okay.
And with Canada, I think they have to make it equivalently available in Quebec, and so like they haven't figured that out yet.
They haven't figured out the French yet.
Yeah.
Okay.
Ren BR says, how could we determine what dark matter is if it does not interact with other particles or light?
Yeah, that's the fun part. So we
Mm-hmm.
keep hoping that rather than being something that is always collisionless, that never interacts, that it's like regular neutrinos where once in every very large number there is a interaction due to a head-on collision. And this is where we're using these vast arrays of different kinds spread out through the world to look for these particles that don't like to interact. So, um, yeah, it is one of the
Yeah, I mean
challenges.
that's the goal. That's the gamble. Is that you create ever larger chambers of heavy water, and you wait for a particle that normally doesn't interact, will
Hmm.
occasionally interact, and then you get it.
Yeah. Heptacular Raptor asks, if gravity is a weak force, could it be the other forces are stronger and also faster? So we know that the other forces aren't faster because
Right.
you don't go
Right.
faster than the speed of light.
Right. Everything
Um,
moves at the speed of light,
yeah,
or the
luckily,
forces move at the speed of light.
hmm so while at very short distances, for instance, the electromagnetic force between an electron and a proton is substantially stronger than the gravitational force between them. Gravity wins in the end because it's singularly directioned, it attracts. Full stop, it attracts. And it adds up. So,
And doesn't it
well,
fall off at the inverse square law, while radiation falls off at the inverse, or magnetism at the inverse cube?
no, magnetism's inverse square.
Something falls at the inverse cube. I think it's, yeah, magnetic fields are inverse cube. So a magnetic field drops at the inverse
Okay,
cube,
so field
while
versus force. Yeah,
right.
yeah. Okay.
Um okay.
I just want to find Maxwell's equations. Give me Maxwell's equations.
I guess it's time for rant then.
Yes.
15 minutes.
So I, who do have access to Bard, I am very sorry. Last week was working on programming with some other folks that were programming in Python, which is not the language I have ever used for doing data visualization. I've always used processing to do data visualization. And so I was learning how to visualize data in Python. And one of the folks looked over my shoulder and was like, no, 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 stop Googling, open ChatGPT.
Mm-hmm.
So I spent one day with ChatGPT open and one day with Bard open. And I'm here to tell you, Bard gives the way I phrase questions much closer to what I was actually looking for results than
That's awesome.
ChatGPT does. And this raised the question of, is ChatGPT the more evil company because it's paying people minimum wage to scrape training data, or is Google, which is just taking everything, the more evil company? And how do you decide? And what do we do when we're trying to avoid taking information from evildoers?
Well, so what is evil about hiring people at minimum wage?
It's it's skilled work. You should be paid enough that you can actually like afford to live, and in this country you can't afford to live on minimum
Sure.
wage.
But isn't that like, shouldn't you have a minimum wage law that's set for what is an appropriate wage?
You would think that. You would
Hmm.
think that. However, we kind of have a problem of only having two parties in this country, so yeah, that hasn't been fixed since the 70s.
Like, what is minimum wage in the U.S.?
Varies from state to state.
And what's minimum wage in your state?
I think it's eight.
Illinois?
I think it's 8.25.
13.
Oh, it's now up to 13? Okay.
Yeah. Um, minimum wage in British Columbia is 16.75, which might actually be less than 13. Let's see. 75 Canadian to US dollars. Yeah, 12.43. So our minimum wage is actually lower than yours now.
That isn't good.
Yeah, yeah.
But at least you get health care.
Sure. Yeah. Yeah. Um, but I think like there's so many flavors of evil.
I
Like I
know,
think
I know.
like I think if a person's job is to examine a response, like doing the remote learning, or sorry, the reinforcement learning human feedback,
Yeah.
that's not a very complicated job, and I think that's a good starter position a for someone who wants to get into a technology field, right? Like, what are you doing? You're doing a search, you are looking at two results, and you're selecting the one that you like better, right? That is like you working in a factory, or you working, like, it's not very complicated work. It's a good starting job. Um, so I think it's when people are doing work that is kind of hazardous and hard on the psyche, like the people who
Moderators.
moderate, yeah, people who are moderating content
Yeah.
that is emotionally damaging.
There's a high suicide rate
There's
in.
no amount of money you could pay me
Yeah.
to make me look through that kind of stuff
Yeah.
and judge whether or not it's good or bad. And so if people are doing that work for minimum wage, that's a travesty.
Yeah.
But be, and so but like, man, there's so many flavors of evil at this point. Like the fact that we don't own our data is
Yeah.
bonkers. That, like, the way this should work is Google, you do a search on Google or whatever, and they say, would it be all right for you to give us these pieces of information so that we
Mhm.
can perform the search for you?
Or can we at least provide you a larger memory cap in exchange? Cuz like I know
No,
I
I
for one am paying them $5 a month to get an extra couple terabytes.
no, I don't think that's worth it. I think, like, you should have complete total control over your data, and you should be able to hand it out on a need to know basis, and whoever is the service provider deletes that information the moment they've completed the service that's
Yes.
required to you,
Yes.
and you should be the only person. You should have a vault with your information, and that you can provide it. And for some people, you're going to have uh, an ongoing relationship, and so it
Mhm.
makes sense for you to provide them the information, but they have to request that information in runtime from your vault, and
And
you give them
that's
permission each time, and they're not allowed to store it locally. And if they get caught storing it locally, they get punished severely, I
and the
think.
Apple ecosystem is working towards that, where you have to
Hmm.
constantly grant access, and every time you update you have to grant access, and it periodically just reminds you of access that you have granted.
Hmm.
And with Google you get asked once and then never updated on how things are changing a long time.
And I think that if we did have that kind of a relationship with our search engine or shopping apps or whatever,
Mhm.
um, you would have, it would be a much more valuable relationship with the search provider, because you could do things like, you could say, I would like to do a search, but here I will give you a list of the 40 things that I'm thinking about buying right now, right? Like
Yeah.
I kind of want to buy a new whatever shovel. I want to buy a new car. I want to buy a new trip. I want to go on a cruise. Whatever. You're gonna have a list of like 40 things that you are kind of interested in right now, if someone could deliver what you need. And that this would be vastly more valuable from an advertising standpoint. And I personally, like, Like, we hate ads when they're untargeted, and we love ads when they're perfectly targeted. The most targeted ad is your best friend who really knows you and makes recommendations for things to buy, and they're always 100% right, and you thank them profusely,
Yeah.
right? That is the best case scenario. And the worst case scenario is just garbage spam ads. We should be able to get to our best friend telling us
Yes.
stuff and making our lives better all over the place, right? Like, oh, I was listening to you ride your bike to work today, and your bike was sounding a little off. I
Yeah.
think you've got a problem with your gear shifter. On your way home tomorrow, stop at this bike shop and they'll tune up your bike for you for $20. And you're like, yes, that's perfect, right? That's exactly what I need to make my life better. But we need that level of sort of, could be, of invasive information. We need to be able to have full control over it. And we chose the advertising paradigm as what is best, because we want stuff for free. And here we are now living in this. All right, I got 8 minutes. So I want to give a different rant.
Okay, go for it.
All right, so here's the rant. The rant is journalism is dying.
Yes.
And
it's brutal.
We're on today. Vice
I saw that.
has gone bankrupt.
Yeah.
And BuzzFeed News was shut down. And like Vice, like in the last couple of years, Vice is awful, right? But you go back to the work they were doing 8 years ago, like they were one of the best people covering the Crimean invasion by Russia. And you're seeing this just happen all over the place. And I think this is part of this devil's bargain with advertising, that advertising is the right way to fund content, is what people believe, and they just don't care. And so you're going to be scrolling through Apple News and you're going to see a bunch of stories, and you're going to go like, oh, here's a story, there's a story, and each one of these stories is some kind of company behind the scenes, and these companies are going to be swapping out journalists for AI content creation. And it's going to be fine, it's going to be good enough, and you're going to be scrolling through it, and you're going to be like, this is fine, like interesting news.
But it's not investigative journalism. We're getting rid of investigative journalism.
Right.
And historically, that has been part of how so many different things have been uncovered, from the latest things with Clarence Thomas in the U.S. Supreme Court, down through a variety of different, I mean, every nation has its things that have been uncovered by investigative journalists.
Yeah. And so it's going to be really tough for artificial intelligence to do a proper investigative journalist piece. When you hear the lengths that some investigative journalists go through to get to the story, and advertising, it's going to be a race to the bottom with advertisement supported media. And the only solution, I think, is for people to like think long and hard about what you love in terms of content, and figure out a way to support that content directly, so that you have a line in with the like don't treat the media as just this, I don't know, this fire hose that rolls past your brain. You're scrolling Reddit, and you're scrolling through Slashdot, and you're looking at your phone, and you swap left on Android, and you look at all the news stories, and then every now and then you hit a paywall, and you go, damn paywall, I hate paywalls, right? Just be cognizant about where you get your content from and what you like, and support the work that is important to you, in whatever form that takes. I think it's not about like just following the advertising and trusting that everything's going to be fine, because these things are going to wink out and you're not going to notice. Like we get a high profile one with Vice or BuzzFeed News, but there's been plenty of low profile ones that are just going to vaporize.
Yeah.
So, And every example that people can provide, if it's supported by advertisement, I think at this point they're on borrowed time.
Yeah,
Like,
I agree.
like if Universe Today hadn't switched over to Patreon in 2013, like if we hadn't
Yeah.
started to push it back then, I would not be having the outlet that I have today.
Yeah. It's
Right.
it's really terrifying how what started as I own an $800 phone and I'm unwilling to spend 99 cents on an app has matured to I want the entire internet to be free and ad free
Mm-hmm.
is just crushing content. Like, I remember when I was little, video games were like $45, which was a shitload of money back then. And now it's all gone to freemium models and pay to play, except for thank God there's stuff like Zelda that you still just pay the actual cost
Mm-hmm.
for.
Mm-hmm.
And yeah,
Yeah, and I don't think we're so accustomed to it just showing up for free
yeah,
that we don't really pay attention to what's happening, and these things wink out.
yeah,
And so I think you and like someone has to pay to
yeah.
make this stuff happen. Like you can't be free. It can't be like if it's free, then you're the product,
Well,
right? You
and
don't want that.
more than that, like I've been watching what's going on with the Writers Guild of America, and
Hmm.
we are seeing the profits being made through the film and television companies skyrocketing thanks to streaming services, while they aren't increasing how much the people who work within the film and television industry are earning. And there is, and this is happening over and over in a variety of different industries, where we see prices going up and the amount of profit going up. And I don't understand capitalism. I don't understand many things. And one of the things that really gets me is how we see in other countries people getting health care and wages that they can support a family off of. Whereas here we see the rate at which the average worker's income goes up is less than inflation, while the rate at which CEOs and all the higher ups are earning goes up faster than inflation. I yeah.
Yeah, I mean, I personally am a huge fan of capitalism. I
I
love
yes,
capitalism.
this is why we need to work together, cuz I'm
Right.
just going over here going I don't like humans.
Yeah.
I
What
the psychiatry of, not
what I
psychology, the psychology of economics breaks my soul.
Yeah, I mean, what I don't like are just ignoring the externalities. And so
Yeah.
I think, like, if I set up a factory next to your house and and I am producing really wonderful products and then I just dump the garbage in your lawn, I don't have to pay to have my garbage taken away because it's just in your lawn. It's on your land.
Yeah.
And I'm laughing, right?
Yeah.
Um so and everybody gets that. Like, is it fair for me to have a factory, make a lot of money, and then just take the garbage and just pile it on your property? And they'd be
No.
like, no, it's not fine. Okay, great. Take that idea, right? And yet I'm making big profits. Well, I would make less profit if I had cleaned up my garbage properly.
Mhm.
I would make less profit if I extracted the carbon dioxide from the atmosphere that I'm releasing. I would make less profit if I made sure that I wasn't putting any effluent into the rivers. So if you make gigantic profits, but you're not accounting for the externalities that you're causing
Yeah.
to other people and the planet, then you're not really making those profits. You're stealing
Yeah.
from the bank of planet Earth, and that's not cool, man. So I think all we have to do, he says, um, oversimplifying, is properly account for externalities. Like stare those externalities right in the face and go, yes, if we do these things, we are stealing from the bank of Earth.
Yeah.
We need to make sure that we don't do that. And even if that means you can't, if your business is no longer profitable because the only way you were able to make it profitable was taking advantage of these externalities, you weren't running a profitable business.
Yeah, you were stealing. That's a good way to put it.
Yeah. So,
I'm going to
and
remember that.
there's been some really interesting estimates where people look at what it would cost to provide for just the value that planet Earth provides us to. Like there is the sun shining that is producing an enormous amount of energy, 1,000 watts per square meter. You've got water, fresh, clean water that falls from the sky. You've got biomass that builds up and accumulates, soil in the ground, pollination from bees and birds and all this stuff. Like there is this enormous machine that is running all the time with the primary input being the sunlight, and we are outstripping really the ability of the sun to replenish all of that. And that we can't do. Clearly we can't do that forever, right? If you just keep taking out more than you have, eventually you run out with catastrophic consequences.
Yeah.
So that's my preference. And then if you can properly account for the externalities, then let capitalism run white hot.
It's okay.
So I love the idea of the free market. I love this idea that I get to wake up every morning and I get to choose how I want to live my life. Do I want to be a writer? Do I want to be a science journalist? Do I want to be a programmer? Do I want to be a gardener? All these kinds of stuff, right? That freedom of how I want to live my life is wonderful, but I can't be living in a delusion that I'm choosing what I want to do with my life, and yet my actions don't have consequences on other people. And I need to be able to live my life without it having consequences on other people, right? I do not have a business if my business is I go into my parents' a kitchen, take all their groceries and sell them on Facebook. That is not a business, right? That is me taking my parents' groceries. We've reached the end of our hour, so it's time to go. And John Suffield's telling us it's time to go. So he's exactly right. Chad says he's working on it. He's narrowed the problem, so we should be good to go today at 5.
Awesome.
I hope.
Awesome. Who are you interviewing at 5?
No, it's my live show. It's my questions and answers show.
Okay.
Yeah.
Cool. All right. So everyone go tune in to that on Fraser's YouTube channel, and life will be good.
5 hours. Yeah.
All right. So that's at 8 p.m. Eastern, 5 p.m. Pacific.
Yeah. And just to warn everybody, we are 6 weeks away from hiatus.
Yes, we are getting there.
Prepare yourself emotionally, spiritually, physically.
I have so much housework to do.
All right. Actually, I did a ton yesterday. I got up at 5 and just did everything yesterday. And it was 9 o'clock at night. And Carl's like, "Are you gonna stop working?" I'm like, "I'm having fun."
I still haven't finished putting the ceiling back up in this room. So it is miles and days better than it was this time last year, because I no longer have plaster falling on my head. But I also I need to finish putting the acoustic panels up, so that will help.
Yeah. Oh, that'd be cool.
Yeah.
All right. I'm going to roll. Thank you, everybody, for hanging out with us today. Thanks to all the moderators. Thank you in advance to all of the people who have to edit and produce this stream into something that the public can use. And we will see all of you next week. Thanks, everyone.
Bye-bye, everyone.